Hello, my young students. Hope you are enjoying completion of syllabus post session. Now, today onwards, as I told in my previous session, that we are going to revise on some important topics. It is very difficult to revise everything, but at least some topics can be revised. Not only topics, some important questions we will discuss so that we are ready for any kind of any type of any moment. If you conduct exam, we will be ready. Okay, right. So I welcome you all for today's session on discussion on some selected questions on the chapter structure of atoms. Okay, right. If number of electrons in an atom is 8 and number of protons is also 8, then what is the atomic number of the atom? Okay. First, let us understand what is atomic number. Atomic number is the number of electrons revolving around the nucleus or number of protons present in the nucleus. Okay. And both numbers are always equal. That's why atom is electrical neutral. This point I told. Okay, and because electrons are busy during some chemical reactions, therefore it is the proton number is taken as the atomic number. Okay, but both are equal. You can take any one number as atomic number, but electron is busy, no, that's why we take a proton number as the atomic number. Okay, and here atomic number, electronic number is 8 and the proton number is also 8. Therefore naturally atomic number becomes 8. Second question is, what is the charge on the atom? When the equal plus equal minus is there, charge is neutral. Okay. Next question. With the help of table 4.1, find out the mass number of oxygen and sulfur atom. Table number 4.1 means what? It gives the number of protons, electrons, and the neutrons. That table is very big. I have not given here. So I will tell what is there in that. So we have to find out the mass number. What is mass number? Mass number is the number of P plus number of N. Number of protons plus number of neutrons, and both are there in the nucleus. Therefore, mass number means mass of the atom. Mass number means the mass of its nucleus. Okay. Or because protons and neutrons are present in the nucleus, I told in my previous session that these protons and neutrons are also called as nucleons. That means mass number means the mass of nucleons or the number of nucleons. Okay, right. So what he has asked here, he has asked the mass number of oxygen. Okay, atomic number of oxygen is 8. Okay, and there are 8 protons and 8 neutrons are there. So when you add these two, you will get the mass number which is equal to 16. In the same way, in the case of sulfur, number of protons equal to 16 as well as neutrons equal to 16. Therefore, mass number becomes the 32. One more question. For the symbol HDT, tabulate 3 subatomic particles, found each of them. What are these HDT? They are the isotopes of hydrogen, deuterium, and tritium. Okay, this hydrogen is called as what? Procium or the proton. One more. Okay, right. Now H. Hmm? So in the H, one proton, one electron, and no neutron. Deuterium, one proton, one neutron, and one electron. Whereas in the tritium, so I have forgotten here. Please write here. In the tritium, one proton, one electron, and the two neutrons. So it is 110. This is 111. Third is 112. So proton number, electron number is same as well. They differ only in the neutron number 0, 1, and 2. Okay, right. Write the electronic configuration of any pair of isotopes and isobars. One sample he has given. Okay, so carbon and the carbon 14, carbon 12 are the two isotopic forms of carbon. Mass number is differs, atomic number is the same. So atomic number gives the number of electrons. So 6 means what? It is a 6 electrons are there. Where they are? So the 2 are in the K, remaining 4 are in the L, because K can take 2, L can take maximum 8. This we have learned with in the Bohr's theory, okay, 2n² formula. So the electronic configuration is what? 2, 4. In the same way, for the isobars, okay, atomic number differs where the mass number is the same. So, but for writing electronic configuration, we want the atomic number of electrons. Okay, so it is 29 to 8, 8 2. Okay, then it is 2 8 8 8 8 to 18. Okay, this is actually 2881. It should be because atomic number of this is not 29, it is 19. Calcium is calcium is 20. Okay, therefore this should be 20, Baba. This is 20. Okay, that's why. So it is 2882 20. Make it 20 here. So accordingly it is 2882 because 18 is 288. Okay, right. So electronic configuration is written if you know the number of electrons or the atomic number in terms of electrons. Okay, right. Now describe Bohr's model of atom, which is very important, very, very important. Bohr's model is compared to the solar system. Okay, he told at the center nucleus is there. Okay, in the nucleus protons are there, and around the nucleus electrons revolving in a fixed path known as orbit or a shell. Okay, and they are also called as what? Energy level. So from nucleus onwards, electrons are distributed. So from nucleus onwards, first is called as K, next is L, next is M, and so on, NOPQ. He has also given 2n² formula where n equal to 1. If n equal to 1, K, n equal to 2, L, and so on, like that. Okay, right. That one he has explained here. So kindly go through. Compare all the proposed models of an atom give in this chapter. Okay, in the 9th class. There are 3 models. In brief, we have learnt Thomson, Rutherford, Bohr. Okay, Thomson's specialty is what? Electrical neutrality, equal number of P, equal number of N. That is the specialty of the Thomson model. Whereas in the Rutherford's model, electrical neutrality is maintained. That is there. What is extra? Extra is he discovered the nucleus. At the center of the atom, small region is there where it is the nucleus, protons are there. So nucleus is positive because of the positive protons which are present in the nucleus. So that is the specialty of what? Rutherford. And the specialty of Bohr what? Bohr said electrical neutrality is maintained, nucleus is there. But the problem of Rutherford was electron was not stable outside. It was due to loss of energy, it will enter the nucleus. That was the problem. But here he said it will not enter. There are 2 forces acting on every electron, one inward, one outward. Both are balancing. Therefore, it is intact. So therefore, it is always revolving around the nucleus. So he has told energy is not lost, keeping in mind fixed path. It is revolving there only. So this is the highlight of the what? Bohr, and he has given the wonderful formula 2n² in different key element shell. That the same what formula you will use in filling the electrons to write the electronic configuration. Okay, right. Now, how will you find out the valency of chlorine, sulfur, magnesium? Valency is calculated on many grounds I told in the previous session. Okay, so let us see here. If the number of electrons in the outermost shell of the atom of an element is less than or equal to 4, then the valency of the element is equal to the number of electrons in the outermost shell. That is 4 only, because neither it can take 4 nor it can give 4, because it can go for the sharing. On the other hand, if the number of electrons in the outermost shell of atom of an element is greater than 4, then the valency of that element is determined by subtracting the number of electrons in the outermost shell from 8. Okay, so if it is more than 4, okay, then it will accept, it will lose electron. How many it is losing? That is the valency. The distribution of electrons in chlorine, sulfur, and magnesium atoms are 2, 8. How it is done? It's here. Chlorine is 17, 2, 8, 8, 7. So outermost is 7. It wants only 1 electron to go for stability. So 1 is the valency, right? So that 8 minus that outermost electrons. Okay. Now sulfur. In the sulfur we have only 6 electrons outermost. It wants 2 electrons. Okay. So 2 is the valency, or 8 minus the valence electrons, that is the 2. The magnesium Magnesium, it is less than 4, no, less than 4. So how many are there? Magnesium is 12, 2, 8, 2. So the 2, it will go for loss of electron. So 2 is lost, 2 is the valency. Okay, right. So some we have discussed here till many questions are there, many chapters are there. So in the time in the due course we'll study. Okay, till then keep studying. Okay, thank you and all.